It's also open source, and it was built and designed by a team from Google, mainly to be fast, and it is crazy fast. And it's important when you're writing more sophisticated web applications. So, lastly, Chrome is built on a multi-process model that's for stability as well as speed. So I'm going to do a quick demo to show you Chrome and some of the neat things you can do with that. Can we switch to the other computer? So here we have, this is Chrome, and we've got a few tabs already open and ready to go here. Google Calendar, iGoogle, YouTube, and Google News. Okay? Now, just a regular web browser, you can scroll up and down. But let's take a quick look here at the task manager. Okay? If you take a look at this, you can see the multi-processes that are running. There's one process for each tab, and there's also down here a process for the plugin. Now, I have this neat little bookmark to create here called Simulate Hang. It's going to throw my current page into an infinite loop. Okay? Notice here, suddenly it's using a whole lot of CPU. I can't click on it. Nothing works in this page, pretty much. You can't type, nothing. However, the rest of the browser is still working. I can still do things. Look at Calendar, iGoogle. I can still type in here if I want to. Okay? So let's go back to this page, and I can see pretty much it's clear that this is using it. And boom. I just killed this one tab. Notice it still works. The rest of the browser is still here. You didn't lose all of your state. Typically, you have many tabs open. And the great thing about it is all I have to do is click reload, and everything's back. Just that easy. Okay? For another quick example here, we'll go to YouTube. We'll start playing our little Flash movie here. Now, in some cases, a Flash app will go crazy and start taking over your application. So here, I'm going to go back to the task manager, and there's my plugin. You can see it's currently using 4% of the CPU. Boom. Terminate process. Just killed it. Now the rest of the page still works. You can still move around. And to get started again, it's just as simple as hitting reload. And everything's fine. Right? And it didn't affect any of my other tabs. Everything else is still here and still works just fine. So the last thing I want to show you as part of this quick demo is creating an application shortcut. All right? So if I come over here, you notice it's a simple little menu option. I'll tell it to put one on the desktop for me. And now, if I go to my desktop and close up these windows, you'll see that there's a shortcut for Google Calendar. Voila. You can go straight to Google Calendar from your desktop. If you switch back to the other projector, please. So that's just a couple of really great benefits of Google Chrome. And you'll notice more than anything that it's just screaming fast. But it's built on top of an open source project that we call Chromium, okay, which is released under a permissive license called a BSD license. And our goal is to encourage others to adopt ideas from Chrome because we're adopting ideas from other browsers as well. For more, Moz has a talk later today on Google Chrome, and I suggest you check that out. I'm going to move on to Gears. Gears is an open source plugin. It's included in Chrome, but it also works in IE and Firefox. Its goal was to improve the basic functionality of all web browsers and extending them to enable rich applications that used to be only possible on desktops. So in our first release, we wanted to put 3 things out there. The first main feature was a local server for offline usage. Wait a minute, offline? What's offline? We have this pervasive connectivity. Believe it or not, there's still sometimes when you're offline, which is kind of sad. So secondly, a local database for storage of data, so caching things. And lastly, worker pools for computation so that you can do a little bit of work without locking up the user's browser. Now, Gears 0.4 launched just a few weeks ago with some notable improvements. First of all, a geolocation API, which allows you to access the location of the user based on their IP address, their cell ID, or their GPS. With a simple JavaScript call, if the users give you permission. It's important that the user's in control of this information. Now, Today, I'm actually very honored to announce that we've added Wi-Fi signals to the geolocation API, which allows developers to get under 200 meters of accuracy as to where a user is in the world. Now, Brad has a Gears talk on that. I'm not going to spoil all of his surprises, but if you're more interested in Gears and how you can do this, definitely check out this talk. The second thing is the Blob API, which makes it easier to access files. And lastly, an on-progress indicator for HTTP uploads and downloads. There's plenty more on this, though, so please check out the Gears talk if you'd like to know more about that. So now let's talk a little about the cloud. We want to make our cloud more accessible to developers. So that means that we need to provide programmatic access to computational resources that we've developed. First of all, that means APIs. And we have two different kinds of APIs that we provide. The first are Google Data APIs. For example, YouTube, Contacts, Calendar, Blogger, Docs, Spreadsheets, dozens more. What they provide is authenticated access to applications and data that our users have put there. So you can use this to build deep integration from our products into yours. For example, you can access calendar events, contacts, and you can get that as XML or JavaScript, and then render that as part of your application. You can also programmatically create calendar entries or contacts. So this is very powerful and enables you to provide a richer integration with our products and something you're writing. The second kind of API is our AJAX APIs. This basically gives you JavaScript access to the public web that we crawl and recrawl and recrawl over and over again. This is a set of read-only REST APIs that give you a way to query things like local listings in Google Maps. You can search across YouTube, Google News headlines, books, images, blog search, web search, even our automatic machine translation capabilities. So together, the Google Data APIs and the AJAX APIs give you programmatic access to our cloud in almost every product we have. And our usage continues to grow, as you can see from this very vague graph that has no numbers on it anywhere. But so I'll tell you one statistic. We currently serve over 1 billion requests every day for our APIs. So you probably want even more cloud access. I'm really happy that we recently released App Engine, which lets you run your apps in our data centers, taking advantage of our scalable infrastructure. It's pretty new, so I want to talk a little bit about what App Engine is. First of all, it's got a really cool logo. It's like a plane without the people. All right? But seriously, it's a system for running scalable applications on our infrastructure. What you do is write Python, you upload it, and we serve it. And it's currently in a preview release, so that means that you get up to 5 million page view requests for your application a month. Once the preview release is over, you'll be able to pay for things over your quota, like computation, storage, and bandwidth. But we built this because launching at internet scale is really hard for developers. Now that there's so many users on the internet, if you want to launch an application, you have to set up a server, like Linux, and you have to configure Apache. You have to configure your database and your SQL database, whatever it may be. Then you have to test it and integrate it with your front-end stuff. Oh, and when you're done with that, you have to find a hosting place, right? You have to get machines. You have to spend a lot of money. You have to set up monitoring. Don't forget to go through your logs. And then as you get more popular, you have to maintain this. As you get more and more users, you have new challenges. You need to get more machines. You need to load balance. You need to optimize. This is a lot of hassle, even for a simple app. Why should you have to do this? What do you want to do? You want to write applications, right? So we make it easy to get started and then to scale with App Engine. So you write your code, you test it locally on your SDK, your developer kit, then simple as clicking a button to deploy it to Google. And if you wrote it carefully using our APIs, your app can scale to millions of users. Now this is just launched, but already there's some really cool apps available for App Engine. This one's called Wordle, and it's at wordle.net. It's a really cool app. You can create word clouds based on text that you provide. You can either copy and paste a bunch of text into it, or just point it to a URL of a web page or a feed. You can see I created this less than a minute by just putting in the URL for App Engine itself, the blog. So it just looks at the frequency of the words and then gives more prominence